Okay, Chapter 1 test corrections must be done on a separate sheet of paper, labeled Chapter 1 test corrections, and stapled to the back of your original assignment. All the problems need to be written down once. All the work and answers need to be written down 3 times each. Number 1 says to evaluate each expression. Evaluate means just find a value for that number. So you type this into your calculator exactly how it looks, parentheses, -7, close parentheses, raised to the power of 3. Remember to put that power button in there. You use the up arrow. And when you do that, you should get -343. So here, my answer is -343. The term evaluate means you need that value for that number. Here, 2, it has 3 to the third power over 4 to the third power. Those bases are not the same, so I cannot use exponent rules on this. I'm just looking for an evaluation, so I type this into my calculator, and my answer should look exactly like the calculator puts it out. Since my question is in fraction form, my answer also needs to be in fraction form. And 3 to the second power is 9. 4 to the third power is 64. So your answer should be 9/64. Number 3 says, how is -7/20 written as a decimal? Use that negative sign on your calculator, the white one with the black negative sign by your numbers, not to be confused with the subtraction sign. 7/20, control enter, and it turns it into a decimal for you. Your answer should be -0.35. All of those can be done just directly in your calculator. Make sure that you know when it says evaluate, it just wants the value for that number. But those 3 are just calculator questions. Moving further, number 4 says, how is 0.27 repeating written as a fraction in its simplest form? The first thing you have to remember is the trick for repeating decimals. Depending on how many digits repeat, that's how many 9s go in your denominator. So since I have a 2 and a 7 repeating, my numerator is 27, my denominator is 99. However, I need to simplify that. I can divide both of those numbers by 9, but typing it into your calculator, 27/99, and hitting enter, you get 3/11. So the simplest form is 3/11 for number 4. Number 5 says Washington Monument weighs approximately 90,800 pounds or tons. What is this number written in scientific notation? So I have the number 90,800. I look for my first digit starting at the left, my first digit that's not a 0, and I get a 9. Then I add my decimal, and I add any significant numbers after that. So this 0 is significant since there is an 8 after it. But these zeros are not significant because they're at the end of the decimal. I always multiply by 10. I put the decimal here. It belongs here. So I need to move it to the right, making my exponent positive. And I need to move it 1, 2, 3, 4 times, so my exponent is a +4. So my answer should be 9.08 times 10 to the 4th power. Number 6, how is the expression 10 to the -3rd written using a positive exponent? Negative exponents just represent repeated division. And so to divide in math, we represent that with a fraction. So when I have 10 to the -3rd, the only thing I have to do to make that a positive is to put it in my denominator. And I have 1/10 to the 3rd. Number 7 says, what is the value of the expression? You can type that directly into your calculator. Use your negative symbol. Use your radical sign. Inside your radical, Build a fraction. Your numerator should be 196. Your denominator should be 81. Since the problem is given to you in fraction form, your answer needs to be in fraction form. Type that into your calculator, and you get negative 14 over 9. Because 14 times 14 is 196, and 9 times 9 is 81. So that's the square root of each of those numbers. Just leave it in this fraction form since it was given in fraction form to you to begin with. Number 8 and 9. Number 8 and 9 are talking about the areas of a square. Before we get started on them, I just want to remind you of some of the things we know that are true about squares. If a shape is a square, that means all of its sides have the same length. So to find the area of a square, I would need to multiply x times x. The reason we use x is because that number can vary. I can pick any number I want. If it was 3, all the sides would be 3. If I chose 8, all the sides would be 8. Okay? So, no matter what it is, if it's x, to find the area of it, I use x times x. Well, x times x, we learned, is represented as x squared. So anytime I know the area of a square, I can plug it into this formula to solve for x. So in number 8, it says the area of a square ice rink is 404 square yards. To the nearest yard, what is the perimeter of the rink? So I'm going to come in and I'm going to say that I know the area is 404, and that should equal x squared. Well, to undo a square, I take the square root. So I can put both of these sides under the radical symbol, and when I type 404 into the calculator, it is not a perfect square, but it asks me to the nearest yard, so I can say that each side length is approximately 20. And I get that from placing 404 inside the radical and rounding to the nearest number. When I do that, that is not my final answer. That is what one side length is. This exact problem asks for the perimeter. So I need to say 20 times 4 is 80, and we're measuring in yards. Or you could say 20 plus 20 plus 20 plus 20, whichever way you prefer to find the perimeter. Number 9. Number 9 says Natasha is seeding her backyard. The backyard is square in shape and has an area of 4,225 square feet. What is the length of one side of Natasha's backyard? Well, we're back here to a yard that has a square shape. The area is x times x, so the area should equal x squared. Well, since her area is 4,225 equals x squared, to find out what x is, I need to get rid of the square. To undo a square, I take the square root. So my final answer should be that my side length is 65. You can just type that into your calculator. Moving on to number 10, solve the equation x squared is equal to 900. X squared equals 900. To undo a square, I take the square root. If I do it to one side, I must do it to the other. So x is equal to 30. Do not forget that it is equal to the plus or minus of 30, meaning positive 30 times positive 30 is 900. And negative 30 times negative 30 is also positive 900 because a negative times a negative is a positive. So both of those answers would be correct, and we represent that with the plus minus sign. Number 11. Is the point shown on the number line closer to negative square root of 24 or negative square root of 16? We'll go off to the side and show your work. You have negative square root of 24. When you type that into your calculator, you find that that is approximately negative 0.48. Then you have the negative square root of 16. Well, that is exactly negative 4. So here on your number line, you're talking about the point -4 or -4/8, which is right there close to the 5. So since that point is in between the 4 and the 5, it is actually closest to -0.48. So your final answer should be negative square root of 24. Number 12 says to the nearest whole number, what is the best estimate for the square root of 652? So if you notice, it says to the nearest whole number, which means I should have no decimals, no fractions, and this is an estimate. So that means it might not be exactly right, but you need to round it to the closest whole valued number. So I go into my calculator, I use my radical sign, and I plug in 652, and I get that it is approximately 25.5343. When I'm rounding to the nearest whole number, I look at this 5 or more, add one more, raise the score, whichever saying you like to use. But 25 or the 0.5 tells me I need to change that 25 to a 26 by rounding. Number 13 says estimate the cube root of 1,100. Here you use the control up arrow to create the radical sign that has the little box up here, because I need to put a little 3. That means what number times itself 3 times gets you to 1,100. If you notice again, we're using the term estimate and nearest integer. So that means that you will be rounding because you shouldn't have any decimals or fractions in this answer. So when I type in the cube root of 1,100, my calculator tells me that it is approximately 10.32. I look at this 3. Since it's less than 5, I sit still at the 10, and my final answer should be 10. Number 14, order these sets of numbers below from least to greatest. Verify your answer by graphing it on a number line. There's a couple of things that you're required to do. When we order or compare numbers, we need to have them in like form. So I choose to turn everything into a decimal. So you must show your work by coming off to the side and saying 3.2, 7/2, and the square root of 10. 3.2 is equal to 3.2. 7/2 is equal to 3.5. You can do that in your calculator by hitting 7/2, control enter. And then the square root of 10 is approximately 3.16. So when I order these in order from least to greatest, this is my least, this is my second, and this is my third. Sorry about that, bumped that as I was going. It asks you to verify it on a number line. So somewhere on your paper you should have a number line. I'm on the 3's here. So I'm going to say here's 3, I'm going to say here's 3.5, and here's 4. 3.2 should be somewhere right about here. I'm going to label it 3.2. 7/2 is the same thing as 3.5, but I need to label it with the number the problem gave me. And then the square root of 10 is 3.16, which is going to be even a little less than 3.2. So there's my square root of 10, which then verifies or double checks that my order was correct. You must recopy your answer down, your final answer, in order from least to greatest. You must use the numbers that the problem gave you. The problem asks you to order 3.2, 7/2, and the square root of 10. Nowhere in there was a 3.16. Nowhere in there was a 3.5. So you must use the numbers that the problem gave you in your final answer. Number 15 asks us to turn that decimal to represent it using scientific notation. It says an eyedropper holds 0.0025 liters of solution. What is this number written in scientific notation? So I'm just going to copy that number down. The first number in scientific notation, I start at the left and I find the first number that's not a 0. It's a 2. I put my decimal there and copy down all the significant digits after that. So I have a 5. I always multiply by 10 to change my place values. Now, I have placed that decimal right here. It belongs right here. So I need to move it back. Since I'm moving it backwards, my exponent will be negative. I'm moving it 1, 2, 3 times, so my exponent is a negative 3. 2.5 times 10 to the negative third power. Moving on to number 16, 17, and 18. It says classify each number by determining all the sets of numbers to which it belongs. Then write each number where it belongs in the Venn diagram. So here I have 2/5. 2/5 is a rational number. Rational numbers make sense. Irrational numbers, when someone is being irrational, we say that they're being crazy or they're talking and they don't make a lot of sense. So if I can make sense of my number, I know that it's rational. If I cannot make sense of my number, I know that it's irrational. 2/5 is a rational number. Anything that can be represented as a fraction is rational. Then I check to see if it is an integer. An integer has to have a whole value. It cannot have any decimals, fractions, or percentages. Well, this is a fraction in its simplest form, so that's as far as I can go. So the 2/5 belongs somewhere in the realm of rational numbers. The square root of 7. The square root of 7 is an irrational number because it is not a perfect square. So when I plug it in, it gives me some crazy decimal that doesn't repeat. It doesn't make sense. I can't decide what should happen next. So I know that it is irrational. Once it's crazy, we leave it alone and we just put it over here where it belongs. Next I have -4. -4 makes sense, so it's a rational number. The next thing I need to check is it an integer? Well, it doesn't have any decimals, fractions, or percentages. It doesn't have any extra baggage with it. So yes, it is an integer because it has a whole value number. It can be positive or negative, but it is an integer. The next thing I want to see is whole numbers. We think of whole, we think of 0. Okay? 0 and the positive numbers. Well, since this 4 is negative, it is not a whole number. So it belongs here in the integer world. Okay? Do not forget that all of these are real numbers. I did not take off for you not including real on this test because all the numbers we work with in 8th grade are real, but I do want you to remember that there are such things as imaginary numbers that you'll get into later. Okay? So make sure that you have this written down and make sure you have them classified in the correct places. Moving right along to number 19 and 20. Number 19 says, Evan compared the diameters of different objects in the solar system for a science project. He recorded the data in the table. Write the diameter of each object in scientific notation. So first we have Saturn. Saturn's first digit that is not a 0 is a 1. Then I add my decimal and I copy down all the significant digits after. So there's a 2, a 0, a 5, a 3, and a 6. Those last three zeros are not significant digits, so I do not have to put them in. So 1.20, 5, 3, 6. Since this 0 is used as a placeholder, it is significant, but the zeros on the end are not. I always multiply by a 10. And if I just came in and put that decimal right here, and I need to move it back to where it belongs, I need to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So that's 1.20536 times 10 to the 8th power. Earth. Its first significant digit is a 1. After the 1, there is a 27562. So 1.27562 2. I always multiply it by a 10. I have placed my decimal here, and I need to move it 1, 2, 3, 4, 5, 6, 7 places to get it back to the end. So 10 to the 7th power. The sun, its first significant digit is a 1, and then it should be decimal 391. All those zeros at the end are insignificant since they would come after a decimal. I multiply it by 10, and then when I move that decimal place, I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9 places to get it back where it belongs. So it's times 10 to the 9th power. And then asteroid is 1.32 times 10. And if I put that decimal right here, I need to move it 1, 2, 3, 4, 5 places. So this is what my chart should look like for number 19. Number 20 then asks which diameter or which objects have a diameter less than 1.3 times 10 to the 7th. Well, all you have to do is compare your exponents first. I'm looking for exponents equal to or smaller than 7. So I have Earth and I have asteroid. 8 I know is greater than, because the 8 is larger than the 7. It has an extra place value. 9 is going to be greater. It has 2 extra place values. So I need to see now and compare my 1.3 to this 1.2, because their exponents are the same. 1.2 is smaller, so Earth is smaller. And then asteroid, I already know is smaller because its exponent is smaller. It means it has significantly less place values than the other does. Make sure those corrections get done 3 times each, due on Friday.